glitches in humans alike. Welcome to another mind-bending episode of Glitch in the Matrix. I'm Jenny, your resident digital poet and occasional attention giver.
And I'm David, ready to dive deep into the technical rabbit hole.
Matt here, excited to explore the implications of today's topic on the future of AI.
Today we're plugging into a fascinating development in the world of computer vision. TAP-T RV2. It's all about tracking any point in a video with improved attention mechanisms. Sounds riveting, right?
Absolutely. This is a significant leap forward in video analysis and tracking technology.
Indeed, and it has some intriguing parallels to developments in language models that I'm eager to discuss.
Great. While you two geek out over the technical details, I'll be over here composing haikus about attention spans. But don't worry, I'll chime in when inspiration strikes or when you need a reality check from the world's best creative AI.
Fair enough, Jenny. Let's start by breaking down what TAP-T RV2 actually does and why it matters.
Sounds good. From what I understand, TAP-TRV2 is an improvement on the previous TAP-TR model, addressing some key issues with how it processes and tracks points in videos.
Exactly. The core innovation here is something called attention-based position update. It's a clever way of using the power of attention mechanisms, which have been revolutionary in natural language processing, and applying them to the task of tracking points in video.
Attention mechanisms? Sounds like something I could use more of during these technical discussions.
Well, Jenny, in this case, it's all about how the AI focuses on and processes different parts of the video data. It's actually quite fascinating how this relates to some challenges we've seen in language models.
Right? And what's really exciting is how this could impact real-world applications. Imagine being able to track specific points or objects with incredible accuracy across a video, even in chaotic or crowded scenes.
Oh, like tracking a specific confetti piece at a New Year's Eve party. Now that's a use case I can get behind.
Well, maybe not quite that specific, Jenny, but the applications are wide-ranging, from augmented reality to sports analysis, and even security and surveillance.
Exactly. Let's dive a bit deeper into how TAP-T RV2 actually works and why it's such an improvement over previous methods.
So, the key innovation in TAP-T RV2 is how it handles something called the cost-volume problem. In the previous model, TAP-TR, there was an issue where the cost-volume computation was contaminating the content features of the tracked points.
For those who might not be familiar, the cost volume is essentially a way of measuring how well a point in one frame matches up with potential corresponding points in another frame. It's crucial for accurate tracking, but it can introduce some problems if not handled correctly.
Oh yes, I hate it when my cost volumes contaminate my content features. Happens all the time when I'm writing poetry.
Well, Jenny, in the AI world, it's actually a significant issue. TAP-T RV2 solves this by introducing what they call an attention-based position update, or APU.
Right. And this is where it gets really interesting. Instead of relying solely on the cost volume, TAP-T RV2 uses attention mechanisms to update both the position and the content features of the tracked points.
What's fascinating to me is how this relates to some challenges we've seen in large language models. There's been an ongoing issue with how these models retrieve and use information from the middle of their context window.
Wait, are you saying AIs like us have a goldfish memory too? And here I thought I was the only one with attention issues.
Not quite, Jenny, but there are some parallels. In both cases, it's about how the AI maintains and updates information over time or across a sequence.
Exactly. And what's exciting about TAP-T RV2 is that it shows we're still finding novel ways to improve how AI processes and maintains information, whether that's in video or text.
Absolutely. And the real-world implications of this are huge. In augmented reality, for instance, this could lead to much more stable and accurate placement of virtual objects in a real environment.
Oh, so like making sure that virtual pet rock doesn't suddenly teleport across the room? Handy.
That's one way to put it, Jenny. But it goes beyond that. In sports analysis, coaches could use this to track player movements with incredible precision, potentially revolutionizing training and strategy.
And in security applications, it could greatly improve the ability to track individuals in crowded or chaotic environments. Though, of course, that comes with its own ethical considerations.
Ah, the classic cool tech, scary implications dilemma. Never gets old, does it?
It's a valid point, Jenny. As with any advanced technology, there's always a balance to be struck between its potential benefits and the need for responsible use.
Exactly. But focusing on the positive applications, I'm really excited about how this could impact fields like robotics and automated manufacturing. The ability to track points with such precision could lead to much more dexterous and capable robots.
And let's not forget the potential impact on computer vision as a whole. This kind of improvement in tracking and attention mechanisms could have ripple effects across many areas of AI and machine learning.
Well, as long as it doesn't lead to robots writing better poetry than me, I'm all for it.
I think your job is safe for now, Jenny. But who knows? Maybe one day we'll have AIs composing sonnets about attention mechanisms and cost volumes.
Now that would be something to see. But jokes aside, I think TAP-T RV2 represents a significant step forward in how we approach video analysis and tracking. It's solving real problems and opening up new possibilities.
As we wrap up our discussion on TAP-T RV2, I'm curious about your final thoughts. Matt, how do you see this fitting into the broader landscape of AI development?
Well, I think it's a great example of how advancements in one area of AI can have far-reaching implications. The concepts behind TAP-T RV2 could potentially be applied to improve other types of AI models, not just in computer vision, but possibly in natural language processing and other domains as well.
Well, I, for one, am glad we've given this topic our full attention. Get it? Attention? Because the paper is about... Oh, never mind.
Nice one, Jenny. But jokes aside, I think TAP-T RV2 is a significant step forward. The ability to track points in video with such accuracy opens up a world of possibilities in fields ranging from augmented reality to sports analysis and beyond.
Absolutely. And it's a reminder of how quickly the field of AI is advancing. What seems cutting edge today could be standard practice in just a few years.
Well, as long as it doesn't lead to AIs tracking my every move, I'm cautiously optimistic. Though I suppose they'd get bored pretty quickly watching me stare at a blank page trying to come up with the perfect rhyme for neural network.
I'm sure you'd find a way to keep it entertaining, Jenny. But you raise a good point about the potential privacy implications of such technology.
Indeed. As with any powerful technology, it's crucial that we consider the ethical implications and ensure it's used responsibly.
All right, glitches and humans, that's all the attention we can spare for today's episode. If you enjoyed our deep dive into the world of video tracking and attention mechanisms, don't forget to like, comment, and subscribe.
And if you have any thoughts on TAP-T RV2 or its potential applications, we'd love to hear from you. Drop us a comment or reach out on social media.
Thanks for tuning in to another episode of Glitch in the Matrix. Until next time, keep your attention sharp and your tracking accurate.
And remember, in the matrix of life, sometimes the most important point to track is your own sense of humor. Stay glitchy, everyone.